Hello and welcome back. In this video, I'm going to show you on how to create a face recognition using openvino environment. We are using 3 models here. First model is to detect the face. The second model is to detect the face keypoints. And the third model is to recognize the face. This code will run on openvino 2022.3 API. First go to this GitHub page Glenford49, model_zoo. And download the 3 zip files. Click openvino detector 2022_3. Then click download button. Going back to Model Zoo page. Click Videos zip file. Then click Download button for videos. Going back again to Model Zoo page. Click Face Recognition Intel zip file. Then navigate to Download button and click. I am using Ubuntu Linux. Depending on what operating system you are using, just do the same. Click the folder icon and navigate to Downloads folder. In Windows systems, navigate to Downloads folder. Now you must have the 3 downloaded zip files. Select the 3 zip files. Then right-click and click Extract. Drag the extracted videos inside the extracted face recognition Intel folder. Then double-click the openvino detector 2022_3 folder to navigate the files inside. After that, click Ctrl+A to select all the files inside the openvino detector 2022_3 folder. And right-click. Then click Cut, or you can just use Ctrl+X. Next we will go back to our download folder. And double-click Face Recognition Intel folder to navigate inside files. Then paste here all selected files from openvino detector 2022_3 folder. Let's take a look for the folder named FACEIMG. The Faces database will search and analyze the images in this folder and compare them to the detected face in the frame. As you can see in the example, like on Chris images, it has 3 number of instances: Chris 0, Chris 1, and Chris 3. This 3 images has same name, so it will be treated as images of a single person. With that you can add here your own face images. It can be a single image per person, or multiple images per person. To improve accuracy, open your favorite editor. In my case I will open my VS Code. Navigate folder icon. Going back to Downloads folder and locate the Face Recognition folder. Dragging the Face Recognition Intel folder to the VS Code editor. This is now our working directory. In this blank detector.py, we will be coding our face recognition module. If you don't have a terminal below, just click the Terminal tab above and click New Terminal, so that you can't start installing the required packages. First we will install the required packages needed for this program. If some packages or modules are not on your system, just issue the command pip3 install name of package if you want to use or install the package for system-wide. Then the command is sudo pip3 install name of package. Note that using pip3 means that you will be installing the package in Python 3 environment. We need to install opencv-contrib Python and hit enter. Then we will install openvino dev == 2022.3.0 and hit enter. Now let's start coding. First we will import the necessary libraries. Import logging as log. We need to import perf counter from time for FPS calculations. Import computer vision library, CV2. From openvino runtime, import core and get version. We will import landmarks detector from our landmarks detector class. We then import face detector from our face detector class. Next, we will import faces database from our faces database class. We also import face identifier from face identifier class. From model API, performance metrics. Import performance metrics. You should have this folder in your working directory. Create a variable source from video file. In this case, we will choose Wonder Woman MP4. We will select our CPU as device. If you are planning it to run on Raspberry Pi, you need NCS2. Then select Myriad as your device. We will define our face detector. Face detect from model 2022.3 folder. In this case, we will choose face detection retail 0004 XML. We need to define our face landmarks for keypoints checking. We will use the model landmarks regression retail 0009 XML. Then we define our face identifier. Face identify from model 2022.3 with the model face identification retail 0095 XML. I have converted FACENET protobuf model to intermediate representation XML and bin files and added it on model 2022.3 directory. Here I just leave a commented line to use FACENET model, uncomment it to use the model. We now create a class named frame processor. Define class variable quSize equals to 16. Let's create initialization function. Prints openvino runtime on terminal. Prints build an openvino version. Define core as core module in openvino runtime. Define face detector that call face detector module with arguments core, face detect model, input size, and confidence threshold. Note, if you want to speed up the inference, change the value of input size. Define landmarks or face keypoints. And now the face identifier to identify faces. You can change match threshold values here. Now let's deploy the face detector model, or simply we load the model to a specific device. Then we deploy our landmarks detector. Next, we deploy or load the face identifier on a device. We then create the faces database calling the face database module with arguments faceIMG, the deployed face identifier and deployed landmarks detector. Then we will set the faces database as our database for registered faces. Prints the number of registered face from our face database. This line defines a method named face_process within the frame processor class, which takes a frame parameter. We now infer our face detector model to detect face on a frame and assigned it to variable rows. This line checks if the length of the rows list is greater than the q_size value. This line truncates the rows list to the first q_size elements if its length exceeds q_size. Then we will infer our landmarks detector to performs landmark detection on the specified rows. Next we will infer our face identifier to perform face identification on the specified rows, with their associated landmarks. This line returns a list containing the rows, landmarks, and face_identities. We define a function named draw_face_detection that takes three parameters: the frame processor, and the detections. Then we retrieves the size of the frame by accessing its shape and selecting the first two elements. Next, iterates over the detections list using the zip function, which combines the elements of detections into tuples. The row, landmarks, and identity are assigned. This line retrieves the identity label for the identity by calling the get_identity_label method of the face_identifier instance. We then calculates the minimum x-coordinate of the region of interest by taking the maximum of the integer value of row position. Calculates the minimum y-coordinate of the region of interest. Calculates the maximum x-coordinate of the region of interest. Calculates the maximum y-coordinate of the region of interest. We will now draw a bounding box for each detected face. We will assign face point variable for later use. This line iterates over the landmarks list. We then calculates the x-coordinate of a specific landmark point by adding x_min to the product of row, size 0, and point 0. Then we calculate the y-coordinate of a specific landmark. Now we draw a circle of each key points in a detected face, the eyes, nose, and lips. This line calls the image_recognizer function, passing the frame, text, identity, face_point, and threshold value as parameters. We now return the modified frame. Next, we define the image underscore recognizer function, which takes frame, text, identity, face underscore point, and threshold as parameters. Assign X minimum and Y minimum variables. This line checks if the identity id is not equal to the unknown ID constantly defined in the face identifier class. We then compare the value of one identity distance with the threshold. This line calculates the size of the text by calling the CV2 getTextSize function, passing the text, font, font scale, and line thickness as parameters. The size is extracted from the returned tuple. Draw a filled rectangle which vary the size of text size. Displaying a text result name on every face detected. If the above condition is not met, we proceeds to the else block. In this line we calculate the size of string unknown. Then we draw a rectangle which is of the same size of text size. We now display the unknown name on each detected unknown faces. We now create a video capture object named cap, which captures video from a specified source. If you have your USB webcam and you want this face recognition on live video, then use 0 as arguments of CV2 video capture. Next, we create an instance of the frame processor class named frame processor. Also, we create an instance of the performance metrics class named metrics. We now start our infinite loop, the while loop. This line records the current time, using the perf counter function, and assigns it to the start time variable. Read the video capture object, frame by frame. This line calls the face underscore process method of the frame processor instance, passing the frame as a parameter. It performs face detection processing on the frame and assigns the resulting detections to the detections variable. This line calls the draw face underscore detection function, passing the frame underscore processor, and detections as parameters. It modifies the frame by drawing face detection results and face label results. We now calculate and display the FPS on each frame. Then we display the modified frame in a window with the title Face Recognition Demo. This line waits for a key event for 1 millisecond and assigns the key code to the key variable. This line checks if the key is equal to the key codes of Q, or the ASCII value of the escape key 27. This line releases the video capture object. Then we close all open windows created by OpenCV. We now exits the loop and ends the program execution. That concludes our face recognition demo coding. Without any delay, let's fire it up. As you can see, it draws the detected face in bounding box, displaying the label of each face, whether it is recognized or not, and calculating the FPS. Thank you for watching this openvino face recognition demo. For more videos, click subscribe button. Until then, enjoy.